Hello and welcome to TGIK episode 172. If you think about that number, this means oh gosh, I'm actually let me mute myself in the monitor. If you think about that number, this means oh gosh, I'm actually let me mute myself in the monitor. All right, there we go. There we go. Okay, much better. All right, there we go. Let's see here. There we go. Okay, much better. All right, there we go. All right, that reverb will go away. So, like I was saying, episode 172, and that reverb will go away. So, like I was saying, episode 172, and that reverb will go away. So, like I was saying, episode 172. All right, just trying to work out these technical difficulties here real quick. Hold on one second. All right, we're back. This will be a lesson to everyone out there. I had YouTube up in multiple. All right, we're back. Oh, did it to myself again. This will be a lesson to everyone out there. I had YouTube up in multiple. Okay, third time's a charm. I apologize to everyone. This is what happens whenever you use Firefox, Safari, and Chrome. I actually had the YouTube for this up in multiple windows across multiple browsers, and I just could not figure out where the reverb came from. So thank you for joining us today. This is episode number 172 of TGIK. This has been going on for years, and I've been around for about most of it. This is not my first or second rodeo here. But I'm Bryan Lyles. I'm a principal engineer at VMware, and I've done quite a few things in the Kubernetes space. But these days, I mostly think about telco and 5G, not the kind you inject into your skin, but the kind that sits on top of towers, and could be fast, could not be fast, but it's still a neat time to actually be in this space. So before we get started, let me see who actually is on today. So hello, Martin from the Netherlands, and Chris Christoph from Germany, and YMO. I'm BCL. Nice to meet you. And then Harsh and Ian from Wales, and Jukum from Finland, and Ryan Perry from the US. Thank you all for joining me here today. And Dima, hello. What we're going to talk about today is profiling apps in Kubernetes with 3 exclamation points at the end. That's about how excited I am about this whole space. And the goal, after we get through the news, I'm going to actually sit down and let's talk about profiling. And instead of just saying, "Oh, here's a product and here's a project," and go look at that, let's actually do something a little bit different today. And let's take it from first principles and try to see if we can work up in a reasonable amount of time to something that is usable. Without further ado, let's see who else just joined in. So we have Waleed. Hello. A Libyan working in Saudi Arabia. Well, it's late for you. Thank you for showing up. And Maz or Mose, I don't actually know which one it is. Hello. I'm glad you all could join me today. So first thing we'll do is we'll get off with some of the news. And let me actually share my screen here. So I have lots to talk about today. It's actually it's interesting that this is a very exciting week, to tell you the truth. And at least in the Kubernetes space, there's lots of good news out there, and I want to share some of it with you. The first item on our list today is that Contour 1.19.1 is shipped, and I actually will not go to its page, but it's the minor. Actually, I will go to the page now I think about it. It is a minor release. And really, it's now about allowing this retry policy and the number of retries to be disabled. I've seen Contour since before, it was even out there anywhere in the world. And I'm just so happy to see that Contour is grown up to be some very, very useful software. The next item on our list here is a prototype is underway for moving kube control or Cuddle or kubectl out of the tree. This is exciting. This is exciting work. We think about that, whenever we had github.com's Kubernetes/Kubernetes, everything was there, and then things were pulled out into, github.com/Kubernetes/kube control. It's still pretty, it was nice, but that was only a mirror. It's nice to see that people are still thinking about how to make it work and on its own. And I just think this is a very exciting project. Please have a look at what I'm going to say it's Pauna is actually doing here. And, send them kudos, or, if you don't like it, let them know why you don't like it. The next item here is GitHub Universe happened this week. And unfortunately, due to the way that the days that end with Y are, I'm just always too busy to sit around and watch a conference online. But I actually did put it on my calendar to check out the replays when they come up, because it seemed like there were some interesting things that came out of there. But I did want to highlight Emily Freeman, who actually did one of the videos they had, and it was actually, I just wanted to share here, it has literally nothing to do with Kubernetes, but Emily's video of computing through the ages is 100% worth the time that it takes to watch it. It is so superbly done. And she deserves a lot of credit, and whoever else came up with the idea definitely deserves a lot of credit for pulling that off. Harbor 2.4 general availability release, which focuses on distributed tracing for enhanced troubleshooting, identifying performance and bottlenecks, has been released this week. There was a blog post by, actually, I should go figure out what this person's name is. So I'm actually going to click on this link. There's a blog post about kubeproxy and the when user space mode. And actually, this is something pretty interesting, is that it's nice to see that work for continuing to make Windows a very valid deployment target for Kubernetes is still going on. And there's actually, I've seen some of these things that are working out, and people are actually putting good work into there. So it's nice to see that kubeproxy is going to support or is supporting when user space mode. Another interesting talk here is we have Katie Gamanji, who I actually was able to give her some space on the KubeCon um, main stage a couple years ago, and she has this panel about what have we learned over the last decade of microservices. This is definitely on my list of things to watch. Even when Katie was at Condé Nast, I was paying lots of attention to the things she says. And now that she's at CNCF, I'm 100% paying even more attention to what she says. And here's just a, I guess more of a notice is that the code freeze for Kubernetes 1.23 is in 2 weeks, in about 3 days, on November 16th. Please have a look at the link to understand, what's actually coming in this release. And because, we all can't use the latest and greatest, older versions of Kubernetes have been updated. So we have updates to 1.22, 1.21, 1.20, and 1.19. The change logs are linked here for your later perusal. An important bit here is that the Kubernetes elections are still happening, and I'm not logged in with GitHub on this computer, so I cannot show you this. But one of the most important bits of our community are the people who actually make our community go, and there's definitely some strong candidates out there, and we should be supporting, the people that are out there making our community better than it is, or better than we ever thought it could be. So if you actually have the ability to vote, you should be voting for those people. And then finally, what we have here is some alumni from my company VMware went off and started a company called ChainGuard with some other people from Google, and they're getting a lot of press lately. So ChainGuard, which actually, this is a lot of words here. ChainGuard, a zero trust supply chain security company. They've just kicked it off. Definitely some good people that I've worked with personally that I would definitely endorse. It's please read about what they have going on. And this idea of zero trust supply chain security is actually pretty interesting, because what we're finding is that in this day and age, it's not your software that needs to be the only secure thing, but really what needs to be secure is the methods that you use to make your software. I think then in other verticals and like manufacturing, we figured this out a long time ago. But now in computing, what we're realizing is that, supply chain security is actually paramount. And doesn't matter how safe your software is, if I can inject an exploit in before you actually ship it. So please take a listen. It's only 14-minute podcast, and I will say I definitely endorse this good group of people, and I'm very anxious to see what they're going to come up with. So now, this is when we get into the interesting bit, and I actually tried to figure out, like, how am I going to do this this TGIK? I can come on here with some pre-baked software, do some demos, make the screen shine, make code bits run, and that would be neat. But I decided today that I'm actually going to start from the zero, start from the bottom on this idea. And what's the idea? Well, I want to talk about observability. I don't like this word one bit. One, because it's long, and I know you can short it to O11Y. It's just a long word. But I do agree with everything that observability is trying to push forward. And to make that even more concrete, when it comes down to observability, when we're thinking about like how it is presented today, where we have this idea of these pillars of observability. So observability is the roof, and we have pillars that are holding it up. And if you think about what pillars we have today, so we have this idea of metrics. And metrics are things that your application can tell the world about itself. And what is that? Well, how much memory are you using? How many requests are we seeing? It's myriad things that we could actually put there, and we can expose as metrics. The second pillar is, we'll call that logging. And logging, from my point of view, is the human readable output from your software that can be used to diagnose how your software is performing at any given time. And it also cannot be human readable. I mean, there's also this ideas of semantic logging where we still can have human readable data, but we can have machine readable metadata around it. And then you have this idea of tracing or distributed tracing, where not only so now we can actually go through an application's process, and we can see in parts of the process, like when we came in on a web request, we can actually see it came in at this time, it did these 15 things, they took this much time, and then it went out at this time. And you can actually, if you use a distributed thought with that, you can actually say, well, now I have all these, these services in the system that are composed together to make something greater than the sum of their parts. And now I can actually see requests coming from a user, and I can see them going through, some front end application on even from the browser. I can see them going through some kind of authentication service. I can see it going into some maybe an inventory service, and then some other kind of other service, and I can actually see the whole flow. And that's when you're trying to make something that can be observable, having that flexibility is something that you need to be able to do. But I don't want to talk about any of those today. I want to talk about profiling. And why profiling? Well, if you think about metrics, traces, and logs, they get you part of the way. But here's a question: how does your software work? What if your software is slow in production? Why? If you didn't put in the tracing at the proper point, are you going to know? And exactly why is it slow? What is it doing? What is it actually? What resources is it commanding? What is it actually trying to call? What parts of what it's trying to call are slow? And we can go even further because we can do CPU trace or profiling. We can do memory profiling too. And we can think about, well, if I have on my desktop, I've ran this thing 100 times, and it's fine. But when I run it in production at 3 a.m. on the third Thursday, this thing blows up and it uses all this memory. How do I capture that state? How do I actually see what's in memory at that particular time? And this is what profiling is going to answer. So before I get into this, because like I said, I'm starting at the beginning on this one. I wanted to go back and take a look at my other screen and see who's actually on the call today. So let me scroll up just a little bit. So hello, Carlos, and hello, Faye, and Dimitri. Hello to you in Oakland, California, and the Popcast. All right, I hope maybe that is Pop himself. Hello from New York City, Carlos, great friend of mine. Good to see you on today, Carlos. And just to let you all know, this is just a warning. I live not in the country, but I live close enough to the country where we have old facilities, old power, old water. And when it rains a lot, things get a little squirrely here. I have UPS on everything, and I think I'm okay, but my power's been out 2 or 3 times today. So I'm hoping that whatever happens over the next hour or so, that we're able to keep it going. So if I just fall off the face of the earth, it's not anything serious. The power just went out. So hello, let's see, we got Dimitri here again. All right, so I'm not going to look at this screen anymore. I'm going to look at this other screen. And like I said, I'm going to start from the beginning about thinking about profiling in Kubernetes. But to get started with that, we gotta, Kubernetes is just one of the vehicles to get us to where we need to be. It's that great set of APIs that allow us to run applications anywhere we want to run them with, say, networking, storage, and let's say not worrying about the container format. Kubernetes is not the end all. It's not the be all. It's just actually a great set of tools to help us get to where we want to be. So before I actually talk about the Kubernetes bits, I want to talk about tracing just in general. And this will be fun because what I decided to do, like I said, this is going to be live, is we're going to start from a terminal today. And we're going to go into an editor, but we're going to start from a terminal. And like I said, I'm just going to make a directory here. And what is this one? PGIK 172. If you see my type ahead, I actually did type this earlier and then deleted it because I said Let's start from the beginning. And what I'm going to do is we're going to spend, probably most of our time in VS Code. And I just want to say, um, um, be kind to me when it comes to VS Code. I don't use it. I like it, but I don't use it. And so if I seem like I'm stumbling around a little bit, it's not because I'm drunk or anything like that, or because I'm just, it's more because I just don't understand VS Code. So we'll get started. Do I trust the authors of files in this folder? I believe I will trust the authors because that's just me. So to get us started today, I was going to dive in deep and type out this huge Go app, but I realized that Go is a great language. It's one of my favorite languages. It's not easy to get started and show people ideas. And a language that is good for that, Swift is good, but I'm not going to type out anything in Swift today because I don't want to launch Xcode. But I want to type out, we're going to do a JavaScript app. And I'm going to use this JavaScript app to actually set the stage for this conversation around profiling. And what this JavaScript app is going to do is, and it's going to do it poorly. And please ding me whenever you see what's going on with the with this JavaScript app. Is that I want to be able to. It's going to do two things. It's going to be able to create a user, and then we're going to be able to verify that user. And the caveat is this. The caveat is because I don't want to do a lot of typing, I'm going to use gets for everything. And I know gets are supposed to be idempotent. So you're going to see me pass data with get that you should be doing in a post. But you know what? This is not about JavaScript today. This is about our good JavaScript. This is just about showing this idea of profiling. And we'll use that as our first tool to get us understanding what we mean by profiling. So with that being said, actually I want to say something else. This is a brand new 2020, what year is this? 2021 MacBook Pro 14-inch. It's the max. It has 64 gigs of storage, and it had of memory and 2 terabytes of storage. This is the fastest computer I own. If you have an opportunity to figure out how to finagle one of these, go get it. I will tell you that the computer in front of me is a 28 core Mac Pro. I'm not kidding. 28 cores. I have 320 gigabytes of memory in this thing. This computer compiles my Swift app that I'm not talking about yet faster than this Mac Pro does. And it's just ridiculous what technology does. So if you get an opportunity to get one of these things, get it. Oh my gosh, it's amazing. All right. Well, that being said, let's type some code. So we're actually in VS Code, and it's nothing in here. It's all just a project that has nothing in there. And what I'll do is we'll just make a directory for our Node app. And Node is particular. I wish I could just start typing things, but we're actually going to create a package.json file so we can download one dependency. So before we need to do that, we'll need to do a init a new file here. And what this is doing is, for people who are not familiar with JavaScript, this is the package.json file. And in the package.json file, all it does is a descriptor for the app, and then we can also put dependencies in here too. So the Node package manager knows how to be able to do what it needs to do. And I'll just get started real quick here and just say that, hey, this is going to be a web app, and I don't want to think about web apps. So what I'll do, we'll just put Express, and Express is just an easy to use web server. And notice that I installed Express, and it downloaded 50 packages. My Lord, that's just crazy. But I'm gonna use Express to be able to just have a web server here. And let's actually look at this. How big is this? For my web server, I downloaded 2.4 megabytes of text. That's great. But that's not what we're here to talk about. And what we're going to do is we're going to put this all in one file. It's going to be one file. We're going to have 2 endpoints. We're going to have a create a new user endpoint, and we're going to have a verify that user endpoint. And let's just get started with those right now. So I will tell you right off the bat, I think I am decent with JavaScript, but I'm not one of those people who'd be like, "Ooh, JavaScript," and it's great. So be friendly in the comments to let you know. Be friendly in the comments because you know what, JavaScript is not my strongest language at all. So we'll start off, and we'll just require Express. This is how you do it, old school. A lot of people are using the new school methods where you can actually do things like where you can actually do the imports, but we're going to do it old school with the requires, and we're going to have this basically saying Express, and then we're going to create an app from our Express. And this is one of the things I like about JavaScript, and this is why I'm using it, is that you can actually be very productive with not a lot of code. So what I've done here is I've created this const called app, which is basically an instance of my Express. So it's an app is an Express, and I'm basically defining a port so we could actually change it with an environment variable later. And then what I'm going to do is I'm going to just start my web server. App.listen, listen, and we can listen on that port. And you don't have to do it this way. I'm just going to say listen on all the ports in case I want to run this in Kubernetes later. And we'll just console log that the server is up. So if I were to run this right now, actually, let me make this about the same size and make this one more bigger. So Maz is asking, what's the plan? Are you planning on profiling a JavaScript app or Golang app? Both. Be patient. It's coming. I gotta work this in there. I gotta work it up. So what we have here is that we just have a web server. So if I go node index.js, and it's going to say the server is up. And if I were to, and we will need another window here. So if I were to go curl HTTP localhost 8000, it's going to say cannot get because we haven't described any of the endpoints that we're going to need. And the first endpoint that we're going to do is we're going to do an endpoint for creating a user. And so, like I said before, we're going to use gets when we should not be using gets. So don't call me out on that one. We're going to do a get to user/new, and it'll create a user. And the user is const username equals query.username or empty string. Const password equals request.query.password or empty string. And what we're going to do with that, user is when we're creating the user is we don't have any storage. I don't want to be persistent. We'll just say it's going to be all memory. We're just going to store it in a variable. So before we do that, we should probably check our input. So if not username or not password or not user's username, that's where we're going to store it. We're just going to return, and we're going to res, and we're going to say that the status is 400. And basically, we're going to say, if you didn't get any of those right, that's your problem. And we're just going to put them in an object. And this is where it gets, I don't know. This is why I like JavaScript, because I can do some of these things so quick. So what we're going to do now is we need to create a salt because we don't want to store the password in memory. What we really want to do is we want to store the password and the password salt and its hash. So the first thing we're going to do is we're going to create a random salt, and we're going to convert it to base 64. All right, let's see here, and we got it to base 64. And then what we're going to do is we're going to make a hash, and we're going to call this crypto. We actually need to import that. Let me import that. Export crypto. Oh no, const crypto equals require crypto. There we go. Now we can use it. We're going to do crypto, and we're going to go pbkdf to sync. So this is basically we're creating this hash with this pbkdf 2, and we're going to call it synchronously. And so we're going to pass in a password, the salt. We're going to do 10,000 iterations on this. It's going to be the key length is going to be 512, and we're going to use SHA-512. We're not going to use SHA-256 anymore because someone was able to do a collision with that and it's not safe. And then we're going to take this username and we're going to put the salt in the hash in there as an object. This is what I like about JavaScript. That's some good looking code right there. And we can do send status 200. So now if we have the username and a password and it doesn't exist, we'll get a 200. If we have a username and a password and it does exist, or the username and the password don't exist, we'll get a 400. So that's the first bit. And then what we're going to do is we're going to create another function that will actually, we'll call it session, or an endpoint called session. So we'll go /session, and we'll go like that. And we'll go, we'll get the request and res, so we can actually use both of those. I clear off some of these windows on my screen. And what we'll do here is on the session is we'll do kind of the same thing we did before. We'll get the username equals request.query.username or empty. Let password equal request.query.user password or empty username. And then what we'll do is we'll do kind of the same thing we did before. So username, password, or if the user does not exist in our little in-memory object here, we'll just basically return a res.send status 400. And the reason we do that is because we don't want to do a 404 if the user doesn't exist, because we don't want people to be able to explore what users actually do exist. And then what we'll do is now we're going to do kind of the same process that we did before, but now we got to check that the password whenever it is actually hashed equals the hash that we have in the memory. So real quick, we can just go salt the hash equals users.username. And then we can do const encrypt hash equals crypto.pdf sync and password, comma salt, comma 10,000, comma 512, comma SHA-512. And then what we can do is we can now do the comparison. So there's a couple ways. JavaScript is really, really expressive. So I can do const is equals crypto.timing safe equals the OG hash with my encrypted hash. And then what I can do is I can just go return res.send status, and if is equal, we can use a ternary here, and we'll just say 200. If not, 401. And that's the first version of this app. So how do we run this app? Like I said before, we can, if we go back to the original screen, we can go node index.js, and then now we can test it out. And this is how we're going to test it out. We'll just do curl http localhost 8000/user/new, and then we'll go username equals Bryan, password equals TGIK, and we should go back. And what this will do is it creates a username. Did I type something wrong here? User/new username. Oh, there we go. I had a bang where I did not deserve a bang. So we'll go ahead and create this, and it says okay because it returned to 200. If I try to create it again, I get a bad request. Now what we want to do is we want to actually validate our session. So I thought that we could just type curl http localhost 8000/session, and then I actually typed this in earlier. So if I type this in, it says it's okay. If the password is wrong, I get unauthorized. If the password is right and it doesn't know, well, if it doesn't know the username, we'll get bad request. So what we want to do is we want to test this because this needs to be performant in production. So what we can do, and I've already typed this out here, is we'll go like this. We'll use Apache Bench. Ooh. am I actually running this? Let me see something here. Username equals Bryan, password equals TGIK. So let me just make sure this is running. Restart this real quick. And do this curl. So create users new, and we'll do this, and we'll need to figure out why this is broken. So /session username is existing, password equals TGIK, and this is why I have other code, because I knew I was going to get myself into a mess here. So let me actually go to my my note file here, and let's see if I can actually get the right command. All right, and we'll just put this in here. And because typing is hard, I'll actually just put this out. I'll just put this in this file. So now what I can do is I can run npm run bench off. And ooh, let me see where my error is here. Did I not do this right? Okay, go back to this command real quick. Let's actually see, what did I type wrong in this command? So Apache bench, keep alive, concurrently run 20, in, and then we'll run 250. It's actually, so let me actually type the curl command out. Actually, okay, so that looks fine. So let me get this and put this there, ab-k-c 20-n250. Oh, I don't need that. Yeah, I am not sure what is going on here. I think, am I on the wrong port? All right, well, we will move on. So the issue, actually, this is what I will do. I will actually just get I will get my script that I wrote before. So I'll go back to my index file, go here, paste all that in, comment this one out. And this is the best part about doing these things live. I wrote notes just in case I got myself into a pickle, and because I wanted to be prepared, but you never know what's going to happen whenever you code live. So now we can actually get this. So we're running the server here, and now whenever we run the curl, let me put this up here. So we create. Actually, I'm using new user in this one. New user. So we created a new user, and then if we go up, if I do this, actually, I think my machine is wrong host. That's what the problem is. Yeah, I don't actually know what I did here. But the problem here is that this is going to be too slow. And if you're actually any bit of a JavaScript developer, you'll be able to see what the problem is. I'm making a synchronous call in JavaScript, and the problem with JavaScript is that there isn't any threads. JavaScript's made to run in a browser, so in the programming model, there's no threads. And what ends up happening is, because there are no threads, oh, I'm looking at this. Am I connecting to the wrong thing? Here, invalid argument 22. Is there a 22 in this file? And then I'm not quite sure. One is off and one is session. And then also the password is different for bench off. I'm glad you all, you know what? There we go, TGIK. I'm glad you all caught that. So let's see here. Let me just try this one more time before I go into this explanation. Oh, I know what the problem is. Good call. So let me run this again. And it says listening to request on localhost. Listening to request on localhost. So if I do curl if I do auth, it says bad request. Username. I gotta put the user in there first. New user. So I put the user in there, and if I do my auth on that, I get okay. So what I want to do now is go AB. We won't use concurrent. We'll just say that there's 20 and number is 250, and we'll put this one in here because I know this works. I wonder what's going on with my with my computer. This actually just worked. Did I put an extra single quote in here? Let's see. Auth username Bryan and password equals TGIK. Let me see something here. All right, grab 8,000. Okay, I actually do have it is listening. I think I'm actually having a different issue here. Yeah, so this is what happens when you do things. And let me look at Apache Bench real quick just to make sure if I'm actually calling it correctly. Um, Apache Bench -K-C. Yeah, I'm seeing this, but so I'm getting lots of feedback here. What the problem is that um, I'm calling localhost 8,000. If you go to this if I go look at netstat and I look for 8,000, I'm actually listening on TCP for 8,000. So I'm just curious of why the curl works, which it does, but the Apache Bench does not work. And you know what? That's fine. I'm set up to be able to do this. So the problem is, and actually, let me just try this one more time. Username equals Bryan, password equals TGIK. Says, yeah, let me actually try something else. Let me get my IP address on my local machine because I know it's listening on here. Um, let me do something here real quick in another window. SSH. We'll just SSH to another machine. Oh no, not that one. We're gonna figure this out. How do you know what your IP address is? Well, it'll tell you. There we go. So if I go back here and I do Apache Bench, because this is my IP address, we'll just see if this is the problem. There, weird. So what's happening here is now this is this call, and it's actually going out, and you're asking yourself, well, you saw the code. Why is it taking all these seconds? Um, why are these taking all these seconds to do this? And if you look at it, it took 13 seconds to be able to make 250 calls. And if we look at the timing on there, it's like the 99th percentile. It's taking 1.3 seconds to be able to validate a user or validate a user in a password. And this is a simple example, but if we think of a more complex example of, you have an algorithm that's running in production, and based on the data and a permutation that you've never seen before, how are you supposed to be able to solve that? And here's the greatest bit. Metrics might be able to show you that, probably not in the way that you want it to. If you were tracing and you actually had a trace span that included where you needed to be, that might work. Logs, well, if you're not logging it definitely won't work. So profiling is actually the answer for being able to solve this problem. But the problem is like, well, how do we do profiling? And then how do we use profiling for great success? And so let me show you how we do this in JavaScript. Um, and then I'll move on to more complex languages to show you how we do this, and then we'll show you how we'll actually explore two ways of doing this in a cluster. So the first thing I want to do is inside of my package.json file, I was running Node. I was running Node index.js to run it before. Node has a built-in profiler, so we'll use Node's profiler to actually spit out some stuff for us. So instead of doing that way, we'll do npm run profile, and it's pretty much the same thing. And we'll go back to my screen here, and we'll go to new user, and we'll create a user, and we'll do the Apache bench again. And what we'll notice is that it's still going to take a few seconds for it to work out properly. So let's let it run and let's see what happens. So 100 requests are done. We should be almost at 200, and then that should only take half a bit. So a little bit slower this time. So now we have 99 percentiles at second and a half. But instead of guessing now, what we have in our directory, what we have is this file here called isolate something log. So if we actually look at this file, the JavaScript people, the Node V8 people were nice enough to basically write down all the profiling stuff. And instead of us having to actually dive through this, what we can do is we can run Node with a flag. And if we look at this, and we'll just throw it out to temp/process.txt. What will happen is it actually is going to replay this. It's going to replay this log file, and it's going to give us some output. And because I put it in, the actual file, we can actually see what was happening inside of our application. So if we go from the top, it's saying something about shared libraries. Maybe you had shared libraries that you were loaded that caused things to be slow. And if we look at this, these shared libraries, even loaded together, are less than 1%, or less than 1% of the actual runtime. So let me look in the JavaScript. JavaScript is notoriously slow, and we actually do have 2 instances of those in there. And what we notice that it's actually a trivial amount of time. It's actually taking 0%. But let's actually look at this C++ bit. Well, actually, let's skip looking at the C++ bit because there's a cheater mode placed at the bottom. At the bottom, it actually tells you what took so long. And if you're on a Mac, the way that these things work is that they actually are moving memory around in an interesting way. So if you use this on Linux, you actually won't see these first 2 lines. But if you do it in a Mac, what you can see is that 97.9% of the call time was that pbkdf2sync method. And like I was telling you before, the reason that is because JavaScript wants you to make asynchronous calls. It likes callbacks. If you have things that block, guess what? It blocks everything. And it actually tells you about where it was. So if we look at app index, so if I actually go and I look at this line, it's going to bring me to the top of this this method here, and we're going to notice that basically it's line 38 that is the cause of the problem. And how can we fix this? Well, I could actually walk you through and say, well, what we can do is we'll actually use a synchronous method or an asynchronous method of pbkdf2sync, and that's the solution. But yeah, so let me show you how to do that. And instead of just typing it all in, since I've copy and pasted it, I'll just do like this. And I have a new version right here in the file. And what it does is this is the asynchronous version. So it makes the same call. It spits the hash back out. And then it calls this function. So that means that whenever this line is called, that it'll release control so something else can run. And what that really means is that whenever, if hopefully that's the case, and that was the reason why we had this. So if I go back to my other terminal and I look at the, let me see, ls-l, we'll get rid of the old one, isolate 0, we'll get rid of that one, and then we'll go node, like push up top. All right, and if we go node -prof-process, use this word right, and we use this file, and we'll put this out into process.txt again. The first thing we're going to notice is that this thing ran way quicker. That's because there was nothing in there. Let me actually do my new user magic first. and then we'll do auth. So the first thing we're going to notice is that the 99th percentile for this run is now 13 milliseconds rather than either a second and a half or even longer, or 1.3 seconds. So just that one set of change, that one change there on that line 58, actually made it so that it's way faster now. And the only way we were able to see that in an easy way was with profiling. And I'm sure that if you're a seasoned developer, you would have seen that instantly that we were making a synchronous call. But what about the calls that are not obvious? And that's why profiling is so important. And that's why we put so much effort into doing profiling. So that's phase one of our project. But you know something, I didn't come to just talk about JavaScript today. I also came to talk about Go and Kubernetes. So the next thing we need to do here is let's cancel all this. There will be no more Go or no more JavaScript in this demonstration, and we'll make a Go app. From me spending so much time in this cloud native space and spending so much time around Kubernetes, actually Go is a lot easier to reason with these days. And so what we'll do is we'll just create one file. And we'll use this file for pretty much the rest of the time. And what we're going to do is we're going to create the simplest web server that I think of that we can actually create in Go. So there's a couple things I would like to do first. Because I'm not running in GoPath, what I need to do is we'll just create this as a module, but we won't actually import anything. So the next thing we want to do inside of our file is what is it, package main, and because we're only going to have one package in here. And next thing we're going to do is we're going to have func main, and so we'll have that as well. And actually, now that we got that far, what I would like to do is I'll just copy and paste the rest of it in, and then I'll just walk through it, and we'll see what is actually going on here. So if I go run main.go, you don't see anything, but because I know in this that we're running on port 10,000, if I do curl HTTP port 10,000, I should get some kind of request. Welcome to the home page. And that's exactly it. But let me walk through this source real quick before I move on to show you what the next section is going to be. So we have this application that we want to run in Kubernetes. Let's say that it's my complex service that makes us lots of money, or it brings us lots of joy. What do I do here? So how would I actually be able to see what's going on in this application when it's running inside of a cluster? First, we'll need to get it in a cluster, and then we'll need to figure out how to get information out of it. And how this runs here is this is the simplest web server. So I put the old school pprof stuff in here from the Go standard library. We won't be using that in here. I want to be able to show, there's got to be a better way that we can actually manage things without being able to expose these types of things. Because guess what? In a lot of cases, the operating system knows. So how can we do that? And let me go back to my browser here real quick. And we'll go make it a little bit bigger. And we'll talk about something that I think is a lot of people are hearing as a buzzword, but aren't really understanding what eBPF is. So let's talk about this for a little bit. It's hard to say, eBPF. Many years ago, the best operating system ever created was created. It was called FreeBSD. And in the late 90s, I could have sworn I was using both Linux and FreeBSD. And I'm like, how would anyone want to use Linux? FreeBSD is so much better. The way that they structured the kernels, the way that you could actually interact with the user space, it was amazing. But one thing that came out of BSD land was this thing called the Berkeley packet filter. The folks at Berkeley have created all this amazing thing. And what the Berkeley packet filter allowed us to do is at a kernel level, it allowed us to write software that actually ran inside of the kernel, and that software that ran inside of the kernel could do all sorts of neat things. And actually, in this page, there's actually a little bit of a diagram. So, like everything good, it was ported from BSD somewhere else, and it was ported to Linux. And now we think about, well, what can we do with BPF right now as an acronym? All these neat things. People are using it for networking. We can actually get the speed of not having to be in user space, and in the lower level, that we can actually create networking semantics that we need. And because we're at the kernel level, we can do a lot more interesting security things. But for our use case and the things that we're talking about today is because we can be in the kernel, we can see every single application that runs. Which, whenever we're thinking about observability, and in this case, really profiling, what we can do is we can actually have applications that run that we don't have to understand. We don't have to tag them with any kind of profiling code, but because they run and we can find software that actually understands what a Go program looks like, so it can actually go through, we can actually do profiling for any type of application or any type of Go application in other languages as well. And this is the new place for us. Imagine being able to deploy an application and then being able to run a system afterwards to figure out a bug that popped up that you had no idea. You don't have to take the application apart. You don't, and in the future, we won't have to do things like making applications dump core so that we can inspect them. We can inspect them in real time. And that's really where we want to end up. And that's actually the only reason I wanted to do this session, because I wanted to say those words. We are almost to the place where we can actually have applications that are running that we can inspect in real time to understand exactly what they're doing. And here's the best part. We don't have to give up, we'll give up a little performance, but we don't have to give up a lot of performance to do it. Because if we think about how profiling works in a lot of applications, either what it's going to do is you basically annotate your application with profiling code, and then it will, if it's a CPU profiler, it actually will stop and it'll look at things. Or if it's a memory profiler, it'll actually snapshot the memory every once in a while to determine what's in there. If we can have access to do this at the kernel, and then the flexibility to change it without rebooting the machine, we built a powerful set of constructs. So for the next 20 minutes or so, what I would like to do is look at two projects that I see that are very interesting in this space. And the first one is Pyroscope.io. It's an open source continuous profiling platform. The neat part is that they actually are working on implicit support for like Go, Python, Java, Ruby, PHP, and .NET. That's a lot of software. But here's an interesting thing. They're also experimenting with eBPF. And what makes it exciting and interesting is this concept right here, where and then you have to do this in Go. If I start a Go app and I want to profile it right now, I have to import pprof. But if I want to use like, let's say, Pyroscope, what I'll need to do, and I want to use their Go support, what I'll need to do is I'll actually have to annotate all my code. I'll annotate every instance of my code with their source. So that means I have to change every single piece of software. And they're realizing with eBPF that I won't have to do that. The second piece of software that they're going to use is Parka.dev. And what Parka is basically it's a similar premise that they basically want to be able to look at programs running in a Kubernetes cluster or anywhere else really, and be able to show you what's going on, not just now, but over time. So let's go take a quick look at both of these applications and let's see if we can get them working. And this will be the fun part. Like, how do we get this working? So I'm in an interesting spot right now. I love computers. Like, I showed you my computer. I showed you my new computer. But it's like, where am I going to run Kubernetes? And one of the reasons I have this big computer that I'm sitting at the desktop on, that I have on my desktop, is So I can actually have a decent size clusters or anything else I want to do, or virtual machines at my fingertips at any time. I don't have to go out to a cloud. I can just have them on my desktop. So what we're going to do is we're going to make one called TGI 172, and we're going to start. Before I do that, though, let me make sure I get the right command. There we go. That's what I want to do. Many cube -p TGIK 172 start -driver equals parallels. And you're saying, Brian, you work at VMware. Why are you not using VMware Fusion? In this particular case, I like how Parallels does networking. So I use Fusion. I have them both installed on this machine. But in this case, we're just going to use this. And someone's saying, well, why am I not using HyperKit? Well, the reason why is because I wanted real Linux. I wanted real Linux and a virtual machine in this case. So, and this is interesting because at right now I can launch on Google, Amazon, or Microsoft. And so GKE, AKS, or EKS. I have a 100 core Kubernetes cluster down like on the floor below me. And actually, I do use Tanzu Community on that one, but I chose to not boot there. I'm just going to use Minikube here. But I also use Kind. It just depends on where in the Kubernetes stack that I choose to optimize for. So if I choose to optimize for just applications running on there, Kind is nice and it's great. If I'm trying to do scale out, or if I want to do some kind of nested things, that's what my my huge cluster downstairs is for. But if I just want to experiment and I think I might need some control of where the I need some control of what's running underneath the Kubernetes, that's what Minikube is for. So you know what? I can't say which one is best, but for my customers, my customers are running telco at cell phone towers, and they're running it in data centers, and they're running it in the cloud. I choose to run it in all those places too. So I built a Kubernetes cluster, and actually, no, Carlos Santana, my cluster, my house is not very toasty. It's in the basement. It's actually only 3 machines, but it's actually not very loud. I put a lot of work into making sure that I don't have a lot of loud machines. And just a little shout out to VMware and that culture. Our home lab culture is ridiculous here. These people that I work with have the hugest, craziest labs, and it's just so amazing what these people can actually do with them. I'm nothing like that. So I built this cluster, 8 CPUs, 20 gigs of memory, 20 almost 20 gigs of disk, just enough for what we're going to do today, which is run that little Go app. So now I'm all running. So if I do get nodes, because I do the alias there, let's see, it's up and running. It's 1.21.2. It's not up to date, but that's fine. So the first thing we're going to want to do is let's actually deploy that app that we just talked about. How do I do it these days? So I'm going to use, first thing I need to do is I need to build an image. And so I need to convert this thing. I need to convert this thing into a Go image. I'm actually going to use Co. Let me see, HTTPS. Let's see, github.com/google/co. If you're not familiar with Co and you're building images that use Go, you're missing out. Co is amazing. It means you don't have to think. If you just write applications in the Go way, using Co makes this so simple. So you're going to see this in a second whenever I actually build this image. So we'll make this that size. There we go. So I'm going to build this image here real quick. And like I said before, you all got to see it run. So I can just go co-publish this directory. This is so amazing to me. I don't know why I love this so much. Co built it and pushed it in like 3 seconds. And now I have this image that I can go use. And that's pretty dope. So actually I'm just looking at the chat here. Someone said, can I run HTOP? Yes. That is what my machine looks like, HTOP. I have 56, I have 26 real cores, 26 or 28 real cores, 28 hyperthreaded cores. Um, I don't, I'm using 65 gigs of real memory right now, and I guess all the rest of this is cache. So if you could just see if you could see my other window, it would be pretty crazy of what I have running. I love running everything and never quitting anything. So this is how I stay sane. So yes, here you go. That's an HTOP for my machine. But keep in mind, this machine is still slower than that MacBook Pro. It's crazy. So we have that image, and if I do a paste, there it is. So next thing we want to do is we want to build a manifest. So we want to do, let's see, create. I do this a lot. So we'll just call it Go app, and we'll just use the command line to do this. And we'll just spit it out to the screen to make sure it's right. And we'll go manifest app.yaml. So that's the first piece we need to do. We need to create service the same way. This is why I love fish as a shell. You notice that my command line history is pretty ridiculous. Oh man, we'll just type foo here because I don't remember what it's going to be. So we'll do like that, and we'll go and we'll just put that in manifest as well. There we go. And then we'll just and because we're using all the editors today, we'll just use them now. No more VS Code. Get rid of a lot of the extra junk. Split these two up, and we'll actually move foo to Go app. There we go. And get rid of this, and get rid of this, and get rid of this. So now we have a manifest to be able to deploy my this application into my cluster, and we'll just deploy that real quick. So we'll go apply -f manifest app, and we'll do I don't know. There's all sorts of things we could do here. I could use like Octant. I could use just get pods. Let's see what happened here. Describe pod this. Oh my gosh. It's always something interesting whenever I use any Minikube on here. What this thing is basically saying is that it doesn't know anything about DNS. So now let me show you how we solve this problem. SSH. So I need to actually SSH into my Minikube. We'll just be good old root. And we need to go into systemd. And the neat part about Minikube is because it's Linux on the bottom and it does use systemd. If you need to change something, you can actually change it. And what this does is I'm just changing it to I'm having DNS problems right now at the house. So we'll just move that one. So let's see if I can remember how to restart system resolver before in a couple seconds. I'm actually going to Google another window. I don't remember these things. Restart system resolved. There are certain things that I will never commit to memory, and this is one of them. There we go. There we go. This is just a lesson for you kids. There's things you need to remember, and there's things you don't need to remember. And restarting the systemd resolver is one short Google search away every single time. So now if I go get pods, it's now running because DNS now works. So now this thing is running in my cluster. So I have an application running. So what I want to do is in the next couple minutes here, let me go back to my my Chrome browser here. Let's see if we can get these either of these working for the eBPF, and we'll give each one 10 minutes because this is like the litmus test. Are we to the place where we can actually get these things running in 10 minutes? And I don't know. This would be fun. So the first thing we want to do with Pyroscope, and let's go to Pyroscope's page again. So Pyroscope says that when you install it, let's see, there's a Pyroscope server and it runs on TCP 4040 somewhere in your cluster, and it has this Badger DB. And what it does is it looks like with the eBPF, oh, interesting. There is basically a Pyroscope. Oh, I'm not going to be able to do this. A Pyroscope process that acts as, it will basically exec my process. So you could do Pyroscope connect. Actually, let's go back down here and see if there's anything else we can do. So you can run it and you can give it some variables here, and then you can run the sudo-e Pyroscope exec. Well, the problem is that I built my image using Co, which means that I have a distroless non-root likely running, so I'm not going to be able to do Pyroscope exec. All right, let's see. How can we do this in the next 30 seconds? What we could do is I could build another Docker file to actually build this, and then I could just make it run as root for my demo. That would be one way. Actually, it doesn't seem like a good way to do that. I don't think we would actually, you wouldn't really want to. Now this puts us in an interesting place where if you run this, that means that you have to run it as root. And to be safe, we tell people to not run as root. So I don't know if that's actually the best idea. Let me close this window so I can actually see. Yes, actually, Evan, I could switch to code base image. Yeah, I could do it. I could do it as an ephemeral pod. I could do that way. Or maybe I could just use Parka because I know, let's see what Parka says in this case. So with Parka, what it says that I could have to do is I basically run these 3 commands, and then I can go look at their tutorial. So let me go look at their tutorial and see if it needs root as well. So it says create the namespace Parka. We'll do that. We'll download the Parka YAML from there. And then it says we do a port forward, and then we install the agent. All right. Oh, hold on. This is really cool here, actually. This doesn't require any change to your running app at all. Oh, well, hold on. I think we'll do this one first. So now I'm looking in the chat here, and I want to comment on some of these things. So notice I said I didn't want to run as root, and then we said, well, we could switch to code base image. So when we switch to code base image, that brings in some interesting bits, and I like to run the distro list as much as possible. But now what that means is that I want to make sure that my developers and people I'm working with run in that idea that they can't run as root. Like our normal modus operandi cannot be root. So yeah, I think we could do that. But let's actually see if we can do things without changing the way that we operate. And then the idea of the ephemeral pod, and actually the privileged daemon set could be, actually that would work too. But once again, it's like, well, are we thinking of good answers or are we thinking of answers? And I think these are definitely answers, but do we want to actually be in that space? So after scanning this real quick here, it looks like this seems like an easier install. So let's actually just try their install. So we're in this cluster. Actually, we're going to use technology here. We're going to put this one over here and this one over here so we can have them both at the same time. Make this one slightly bigger. So what we need to do here is it says we need to create a namespace for Parka. All right, looks good to me. The second thing we need to do is we need to apply this manifest. Once upon a time, I wrote a tool that would allow you to download a manifest and inspect all the contents before you applied it, and I can't find it. This is what happens when you get older. So we're gonna have to do this the old-fashioned way. So what we'll do is we'll go into manifest and we'll just go. We'll use wget, and and we'll just look at it by hand. So what we have in here, well, we didn't have to create the namespace because it already did that. Then what we get is a config map with some configuration for the application itself. And then we have a deployment and some labels on there. It runs the Parka binary with that configuration that we probably going to mount it in. Yep, I see it with here. So we're just basically going to run that. And wait, hold on. Hey, Parka people, if you're on this call, you create a namespace up here. Oh, crap. Let me actually load this up in Vim. It'll be easier to see. So let's look at this again. So we have a namespace, we have a config map, we have a deployment, and then we have a namespace again. Oh, I see what they're doing. They actually are using some kind of, maybe they're using Customize or something to build this on their way out. And they're building all the parts separately because they have the namespace there twice. And then it has a PSP. Interesting that PSPs are going to go away. So it'd be interesting to see how they're going to move with this after PSPs go away. And then we have role. And then we have a role binding. Okay, what does this role do? It just has API groups for policy and allows us to look at the pod security policies. And then we have a service, and it looks like it runs on port 77. So we'll go take a look at that. And then we have a service account that actually is probably in the role binding. And it is. And let's see, I'm looking in the things here. The labels on the namespace are the PSP replacement. Okay, got it. Yes. All right. So now we were able to look at this. Let's install it. So I mean, it's okay. Apply -f Kubernetes manifest YAML, and there's Kubernetes saying what's up. We have a little bit of time for that, so it's not dire emergency, but always nice to think about. We get kpods -n Parka. Something's happening, but we don't know it yet. All right, we'll just watch that for a second. Oh, no need to. It's now running. And let's see what it says. So we did the Parka, we did that piece. Oh, we need to do a port forward. I'm gonna do that somewhere else in another screen because port forwards are not fun. So I actually have set up a port forward on another screen, so it's there. So now what I should be able to do is go to localhost 77. Oh, and it's running. Nice. So let's close this. We have too many windows open. So next up, we have to set up the Parka agent. And what the agent does is, from what I'm ascertaining here, is, well, actually, you know what? Let's not guess what the agent does. Let's see what this says. Do curl-l-o Parka agent.yaml, and we'll grab this bad boy. And then we'll go look at the Parka agent. Okay. So now what we have here is another cluster role for the Parka agent and a cluster role binding to go with it. And we have a daemon set up, so it looks like that means that the Parka agent runs on every single host. Okay. Runs on port 7071, so we'll probably go take a look at that in a little bit. Mounts a lot of local, and oh, look at this. Lots of local mounts. This is interesting, but very much needed. I mean, I can see why this would be needed. Like you have the BPFS and you have all these things there. So because look, this is a low level tool. It's going to actually have to mount a lot of things. Makes a lot of sense. Let's see. Um, Making sure that all those volumes that we had were mounted. And then we have this pod security policy again. And then we have another role and a role binding. What's this role do? There's this policy here. Okay, got it. And then there's a service account, very similar to the last file. So what we'll do now is we'll apply this to my cluster. And k-n parka get pods -w. Notice that it looks like the agent's up and running. I only have one host on this cluster, so because it's Minikube, so it looks like it's all up and running. And now, what does it say do? It says now that we have everything up and running, we're going to set up a port forward. And because we have multiple ones that could be running, we're going to run this command here. And I'm going to run another screen, but I'll actually say what it does for people who are paying attention. We're going to run this part forward, but we're going to take the output. All right, 1 second. 1 second. All right, there we go. Um, there we go. So I've moved to headphones here, and you should be able to hear me again. I 100% apologize, but if you pull up a map and look at the East Coast United States right now, you see that there's like a crazy storm going up the East Coast where people are flooding, and I'm sure it's not going to be great for some people. So I consider myself extremely lucky to be able to do this when there's literally no power in my house and we're running off battery right now. But we're going to get through this. So, like I was saying, um, what this port forward does is it basically just looks for a Parker agent. It gets the first one and it maps that in there. So what I'm going to do is make sure I actually ran that command and that my port forward is actually running. Oh, I got it. Oh gosh. There we go. Oh man, I'm just showing all sorts of things I shouldn't be showing. Oh, power came back on. The power just came back on, but I'm not gonna trust that. So now we have port 7071, and if I go to localhost 7071, hey, look, now we're getting the output from the agent, and it's just one of the agents. Well, it's actually the only agent. So what I want to do is see if the Parka agent actually got my thing. So let me take a look at this. Oh, I see it. So this means that my application was found by Parka, and I didn't have to do anything for it to be found. And so that's a pretty cool feature. So let's go back to their guide here. So we're able to look at this. And now what we want to do is we want to be able to look at the profiles. So if we go to profiles, all right, click on this, we can get CPU samples. Pretty cool. And if I do search, what's going to happen? Well, we're going to get something out of here. So if we look at this, you notice that the top one was Parka itself, it looks like. And let's see what else we have on here. We have Kube API server, API server. We have Kube proxy. Oh, I will zoom. Let me zoom a little bit. Thanks. Let me do it like this. There we go. There we go. So we have all the things that are running in this cluster. And if I go towards the right, let's see. Oh, I can see my Go app. So if I know these folks like I think I know these folks, let's see. I wonder if I can do something like type namespace equals default in here. And let's see what happens. Oh gosh. I love good defaults. So now I can now see my Go app that we deployed. It's being profiled, but you notice that it says there's no samples. And the reason why is because we haven't done any work. See, we haven't worked that thing out at all yet. So what we need to do is, here real quick, is we need to figure out how to send that thing some traffic. So what I am going to do here is get service, see what services we have running in this cluster. We have Go app. In my other hidden screen here, I'm just going to do a port forward. So we're going to port forward. Let's see. So we're going to go, okay, port forward service / Go app. And we'll put that on port 10. I'll put it on 10,001. So 10,001. It says service Go app does not have a 10,001. Oh, I typed it wrong. 10,000. Oh, actually, let me go look at my, it's 80 to 10,001. All right, 1 second here. Let me go back in here and look at this real quick. So if I look at my app here real quick, there, let's just do this. Okay, app, apply -f app. This will make it easier to type in my other screen. App 10,000. There we go. So if I go to this machine and I do localhost 10,000, I should get my welcome to the home page. And we'll do it like, I'm just hitting reply or reload. So we got that like 10 times. So now if I do a search, and I'll give this thing about 30 seconds to catch up. My assumption here is that we should have caught some samples. And if we catch some samples, then we can actually go look at our app. So we'll give it a second here. Actually, while we're waiting for that to happen, let's go look at some of these other samples that we have. So I have this Parka agent, and it's just right now towards the right part. It's actually pretty high. What can I see on this thing? Oh, well, here we go. So I clicked on it at basically 927 UTC, and now what we get is a neat kind of icicle graph. And now what I can do is I can determine where all the CPU is being used in my application. So if we go from left to right, let's look at this one. Um, this right here, this is Go doing what Go does. So we can ignore some of the things that are kernel but let's actually look in the Parka agent one, and we can actually see what parts of the app are actually taking lots of most of the usage up. So we can actually see that we did not put any of this in our app ourselves. We didn't actually code this. We didn't have to add any kind of profile or anything like that. It picked this up because it knows what Go looks like from the kernel level. It's pretty dope. So let's actually reload this page here again. Oh, I think my thing would have showed up now. Let me paste this back up in here. Oh, it did not. While we wait, let me actually do an Apache bench. I know I have one somewhere. There we go. So what I'm going to do is send it, I don't know, this is Go. So let's send it 100,000. We'll send it 100,000 requests at 20 concurrency, but we'll keep it lives on. So now I actually have Apache Bench doing this, whatever it's doing. What I hope to see here, it says, can you list the CPU time consumed by each function? I don't know. Let's actually figure that out. Sorry about that. I hit reload on the wrong screen. My bad. Nope, not that one. All right, I'm back. Just making sure. Just making sure I'm back. Audio. Okay, I'm back. I hit reload on the wrong screen. So what I hope to see in a little bit is that the graph actually goes up because it's actually serving request. So, let me hit search. Oh, there we go. Perfect. So this is all of our synthetic traffic that actually hit this cluster. Hit this application running in the cluster. And if we go and we click on this, so we clicked on this one now, we can now see what this application was doing. So if we go over here and we're looking at the runtime, we can move past these. But what's more interesting is from my package itself. So my TGIK-172-Go. And you notice that HTTP was actually a very big consumer of CPU, and then serve. And then if you look down here, there's a lot of buff.io, read line, read slice. This is because I'm just sending back a whole bunch of text. So what we were able to see here in my very trivial, like literally trivial example, is that that Parka was actually, so if I click on this, Parka is able to see what's going on in my application, and I don't have to do anything. And the neat part about this is that if I go back and actually, let's do this while we're on here. So we will quit this and we'll go SSH so we can actually be on that host. And we go, I'm just looking at top here real quick. And what I'm looking for, because I know it would actually show up, is if the polling process was taking up a lot of the CPU, it would show up here. And notice that it's actually not showing up here because it's in the kernel and that information is already available. So no, pretty cool that this is able to be able to profile without actually taking up lots of CPU. So this is what I'm going to say. I wanted to look at Pyroscope, but I don't know how long power is going to last. So this is what we're going to do. I'm going to write the show notes, and I want to say that we need to, as a community, we need to think about that there's more than 3 pillars when it comes to. Let me actually put my serious face on. There's more than 3 pillars when it comes to observability. We've figured out We figured out the shape of metrics, we figured out the shape of logs, and we figured out the shape of distributed tracing. All three of those have a lot more way to go, become more accessible and more used by teams. It should not be a challenge to do any of those. But at the same time, we need to think about other pillars of observability. And you know, I will say that profiling is definitely going to be one of those. It might not be the only one, but it's going to be one of those. So we're looking at the tools. The open source community has um, already hopped in there. Hey, Bryan, I would love to do Pyroscope, but Mother Nature says no today. But look at this open source right now. We have Pyroscope, we have Parka. People are starting to fill in the space. And then we have all the work that's going on from eBPF, whether it be networking or tracing or other things that eBPF can do. So I want to say that this is an exciting time. Thank you all for sticking with me. My gosh, this was definitely an event. And really, I just want to give a shout out to all the maintainers for making this great software and making it open source so that we can talk about it on Fridays. And I want to thank all of you all, especially Pixie. That's right, Pixie was picked up. Someone's mentioning Pixie. Pixie was picked up by New Relic not too long ago. So there's definitely lots of people who are trying to fill in this space. This is a good time. But I do want to say thank you, everyone, especially everybody in Europe and Asia who joined me tonight. It's late and it's Friday. You could have done anything else, but you chose to spend time here. Really appreciate that. If there's anything that I missed or was wrong or anything else, send me a DM on Twitter. If you can figure out my email is, send me an email or find someone that has. I think this is just the beginning of this conversation around all these things, and we have so much more work to do. So thank you to all the maintainers and all the community for making space for this. So that's it. Thank you all. Good night. It was great.